Welcome back, students. Question number 4. We are starting from where we left in previous video. We are doing exercise 7.1 and we finished up to question 3. So today we'll be doing this question number 4, and we'll do other questions also, but in this video I'll be doing question number 4. So as you can see, question is, L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC congruent to triangle CD. Okay, look, this one is actually parallel line. I've given this in symbol. This is parallel. Okay, so L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle is this. Okay, so L and M are two parallel lines, as you can see in diagram. This one is M, this one is L. So L and M, these are parallel to one another, isn't it? That's what they have said. L and M are two parallel lines. Okay, then intersected by. Intersected means someone will go across this. Will cross this line. Okay, intersect means it will definitely cross somewhere. So see, intersected by another pair of parallel lines P and Q. So where is P and Q? This one and this one. You see, they are cutting this L and M. You see. That's what they are saying, intersecting. Show that this is congruent to this. Okay, show the triangle ABC. ABC, this triangle. Look, here we are getting one triangle, yes. Congruent to triangle CDA. Okay, got it. So in the beginning, also in the introductory part, in our first video, I told you that in this chapter you will be getting two triangles anyhow. Either you will get two separate triangles, separate, or else you'll get one big triangle. Inside that you will get many smaller triangles. Okay, here you are getting, see, under one quadrilateral you are getting two triangles. Okay, so what I'll do now, we'll start solution part. Given, look, in geometry it is always better, or it's just like a rule that if you always have to start with given. Okay, so write given. What is given? L and M are two parallel lines, so you can write L parallel M, common sense. Here they have written L and M are two parallel lines. In sentence, here you can write in mathematical language like this, L parallel M. Intersected by another pair of parallel lines P and Q. So P parallel Q, this is also parallel. To prove, yes, you see, show that this congruent is, so you are writing to prove. And prove. See, here comes the most important one. Under proof, first of all you will take this one, this condition. What is this condition? L parallel M. You see, L, yes, they are parallel. And what I have written? L parallel M and AC is the transversal. So see, L parallel M and AC is the transversal. Yes, it is just like this. See, suppose there are two parallel lines. Now if one line comes like this, suppose like this, okay, then I cannot say that this line is diagonal. Okay, diagonal comes under that figure which is a closed figure. Right now it is open figure. Okay, not close from this side, not close from this side. So suppose, like you can see in diagram, here are in our this question we have L here, M here. So L is parallel to M, and this one, this is A, this is C. Okay, so this AC is not our diagonal here, this is our transversal. Alright, so whenever any transversal is made between two parallel lines, what will happen? Well, you should know, I won't say this, you can see from figure. Try and understand. I have already explained you this part. So L parallel M and AC is a transversal. L parallel M and AC is a transversal. Okay. Then I have written angle ACB equal to angle CD. Angle ACB, that means this one. ACB. Then angle CAD. 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 This one. Now what type of angle is this? What type of angle? Guess. Yes. Some of you may be getting, some of you may not have any idea. Yes, anyone? Pretty sure? Christina? Yes, who can guess it? This is shall I say? Okay, this is alternate interior angle, because you see one angle here at the bottom, one at the top, and their direction are different. They are not on the same side. Okay, so this is alternate interior angle. So angle is equal to angle CD here. AIA. You will write in spelling. Okay, then so this is equal to CD we got when L parallel M was considered. This parallel this. We also know that this P and Q are parallel lines. So at a time again we'll consider similar case. P parallel Q and S is the transversal. You can see this one and this one. P parallel Q. See, again earlier I drew now like this. Okay, this is P, this is Q. Then suppose somewhere I have cut it like this. This one A, this one C. Look, here we have other name. No need to worry about that. But right now, if we see this line P and Q, they are parallel, and they are connected by this line. And this is not diagonal. We cannot say this is diagonal. Okay, this is transversal. So that's what I have written. You see, and since P parallel Q and S is the transversal, therefore angle BAC equal to angle DCA. Angle BAC equal to angle DCA. How I got this? You see, BAC. That means we are considering this one. BAC. Okay, here I can give little bigger or little smaller. Should not be same with this. I am holding camera and looking at copy myself. I mean at the same time. So hopefully you understand. We cannot give this same. All right. Either this bigger, this smaller. Here I try to give this bigger. Okay. Then next. So BAC equal to DCA. DCA. That means talking about this DCA. A was this, so that's what I have written here. Angle B is equal to angle DCA, and again here alternate angle. So AIA. You write in spelling, and I have given Roman 1 and Roman 2, so that we don't need to write here again and again. Okay. All right. We have got 2. Look, whenever you need to prove some triangle is congruent to some triangle, you need to get 3 anyhow. And out of these 3, you already get these 2. See, you need to. That means you need to find 1 anyhow more. Okay. So in triangle ABC and CDA, in triangle CDA, why I am considering these 2 triangle? Because you see, it proved this one and this one. I am not writing this as for time pass or just for a decoration or not just to make an answer lengthy. I am going according to target. So this was our to prove. That's why I brought this. In triangle ABC and triangle CDA, ACB and CD, I have got it somewhere. You see, ACB and CD. I got this earlier itself. So this was 1. So I have written from 1. Angle BAC equal to angle DCA. You see here BAC DCA. This was 2. So 2. We have got already 2. This one was earlier one. And we got previously. Then finally, look, we have already got 2. We need 1 more. And how can we get 1 more? This is always the easiest one. Some of you, even if you don't understand this maths completely, you can always find at least 1. That's the easiest one. Okay. In this triangle, which letter comes again and again? You have to see this. From there, 99% of the time you will get at least 1 from here. Okay. So AC is coming again. So you read ACC common. Therefore, we have got 3. That's why therefore this congruent to this. ASA. Why have written ASA? You see, this was angle side. It means 2 angle 1 side. So you can write ASA rule. Okay. Look, here I have done it. Here we have taken more steps. Without doing this also, we can directly start from here. But you always have to make your concept strong. If I don't write this, then you may forget after some time, right? But after lots of practice you can also do like this. See, instead of writing here to here, you can directly start from here. What you'll do every time in triangle ABC and triangle CDA, yes, you'll start with this. Then angle ACB equal to CAD. Angle ACB equal to CAD. See diagram, ACB CAD, that means ACB, this angle, and CAD, that one. So this is alternate angle, isn't it? So instead of from 1, you can write alternate interior angle in spelling. Okay. Then second one also, BAC equal to DCA. Instead of writing from 2, you can write alternate interior angle. And this ACC common is same, so you don't need to change about this. And how we got this alternate interior angle? We got this alternate interior angle only because of that AC, that transversal. Okay, so this AC is very important, and that's why I wrote this previously here in details. Now here I'll first of all practice with this. After you have done enough practice, you can directly come to here. Okay, this much for this video. Thank you.